All right, question number 8. Again, we have a chain rule question. We have some function to the fourth power. This is just like having u to the fourth, and we know that the derivative of u to the fourth is going to be 4u cubed times u prime. All right, so I have f prime is going to be 4 times this function, x squared plus 8 plus the root of x, raised to the third power. And now we just need to multiply by the derivative of what's on the inside here. All right, derivative of x squared, that's an easy one. That's just 2x. The derivative of 8, well, that's just 0. And the derivative of the square root of x is 1 over 2 radical x. Right, that should be something that you should generally be able to like regurgitate at this point. You don't want to do x to the 1/2 x to the negative 1/2, bring it down. Come on, that's what we do if this were like math 19 or something. 19, 119, math 19. I don't even know if you have like a math 19 here. It'd be like really, really easy math. Question number 9. We have a chain rule. Ooh, it looks like we have a chain rule and a chain rule. So for starters, we know that the derivative of the natural log of u is u prime over u. So whatever's on the inside just ends up in the denominator. So that part's going to be nice and easy. But then when I go to take the derivative of the square root of tangent of x, well, that's going to actually be another chain rule, right? So we have the square root of some function square root of u. So if I took this, it would be 1 over 2, whatever I already have, times the derivative of whatever's inside here. So that's going to be a secant squared of x. And this is also over the root of tan x. So we could, if we wanted, do a little bit of combining, right? So I would have secant squared over 2 tangent of x. So if I wanted to, I could write this as secant squared of x over 2 tangent of x, 2 rad tangent of x, over another rad tangent of x. These two things can be combined. We can kind of squash them together. Secant squared of x, 2, well, radical tangent times radical tangent is just 1 tangent. So this would be 2 tangent of x. And we could write it that way if we want. All right, so other ways that you could have done this if you wanted to be like, I don't know, a math maven, some math guru, if you want to, like, I don't know, start working at the math center or something. I should hit the cough button on the microphone. I shouldn't just cough off into the distance. We could write the square root of the tangent of x as the natural log of the tangent of x raised to the 1/2. Right, and because we have a natural log of something to a power, this power can come down front. We can write this as 1/2 natural log of tangent of x. If we took this derivative, it would be a little bit easier. The tangent of x would end up in the denominator. The derivative of the tangent would be secant squared of x. And that would be the exact same thing that we got over there. Look at that. Math working out. And then last one here, 3x squared plus e to the negative x squared. Right, this isn't going to be too terrible. Right, this is 3 to the u. So dy dx is going to be u prime, so 2x, the function itself, let me go natural log first, times the natural log of the base, natural log of 3, times the function itself. And then e to the u is going to be the derivative of the exponent, which is negative 2x, e to the negative x squared. All right, so that would be our function. And can we clean that up? Yeah, we can clean up, I don't know, like an x squared or something. If I wanted to, I could pull out a 2x and just be left with the natural log of 3 times 3x squared minus e to the negative x squared. We could also do that. All right, that's it for this first page. Oh, now it's about to get real on these next ones.